a Kaggle Grandmaster with most of my experience are in computer visions. Five of my 6 gold medals are about computer visions. So I think the key points of my solution is to refine the sparse label to dense label. And this is also the title of my solution. And in my solution, I'm going to firstly introduce my summary and some important key points of the solution. And I'll introduce each of the key points in the late parts. And finally, I'm going to make a ablation study and some discussion. So my solution contains only 2D models, and the code is implemented with 3 popular Python package, which are PyTorch, Team, and Segmentation PyTorch. And the segmentation models I used is UNet and UNet++, and they uses 3 kinds of backbone, which is MaxVIT and EfficientNet and SE-ResNext. So, and the important key points are listed here, and I'm going to introduce them lately. So the first important key point is that I refined the sparse label provided by the host with the pseudo label strategy. The reason why I take it as the most important part, because I think there is only one kidney for the private test set, and I think this private test set should only cover a very narrow data distribution, and I hope my models can cover this very narrow data distribution. So this model should be trained on as many kidneys as possible. But half of the kidneys in the training set has sparse label. And I think if I directly trained on these kidneys, they may bring some noise. And I don't hope my models to learn this wrong information. So I try to refine these labels with the pseudo label strategy. So and a simple pseudo label strategy is to make the pseudo label on both of these kidneys, kidney 2 and kidney 3 bars at once. But I don't think it's the best strategy. Instead, I first make a pseudo label on the kidney 3 bars, and then I make the pseudo label on kidney 2, and trained on all these kidneys. So why I first make the pseudo label on kidney 3 sparse? Because I think the kidney 3 sparse has a very similar data distribution to the kidney 3 dense, since they are from the same kidney. So if my models are trained with the kidney 3 dense, it may perform very well on kidney 3 sparse. So in details, at first I trained a UNet with MaxVIT and another UNet with EfficientNet v2 using all the dense kidney. And then I used the model trained in step 1 to generate the pseudo labels for kidney 3 sparse. And then by combining the pseudo label and the sparse labels, I can train on the kidney 1, kidney 3 dense, and kidney 3 sparse plus pseudo to resume the training of the models in the step 1. Then I can repeat step 2 and step 3 on kidney 2. And finally, I get the refining label of all the kidneys. Then I just discard the validation set and trained 4 models on all the kidneys. So the way I combine the pseudo label and the sparse label is to utilizing the proportion provided by the host. For example, after I inference on the sparse kidney, I just save the mask in float format. Uh, since the since if we want to use this as the ground truth we trained, we should binarize them. But we don't know the optimal threshold to binarize the prediction mask. So I span the threshold, and we can at every threshold we can compare the prediction mask and the sparse label, and also we have a proportion provided by the host, and at each threshold with the true positive rate and false positive rate and the false negative rate, we can pick a threshold that make the prediction mask plus the sparse label has the closest number of pixels to the proportion provided by the host. And I think another key factor is that the training set and public test set and the private test set has different magnification. And in short, the kidney in the test set is about 80% smaller than the kidneys in training and public test set. So while training, I set the scaling factor to 0.8 to simulate this magnification. And another key factor is that since the total number of the slices of the test set is 1,500, and the private test set only have 500 slices. And I think if while inference, an important test time argumentation trick is that we should inference along each axis. But if for example, if we inference on the x-axis and the plane contains y and z axis, but the z-axis is very short, and another choice is that we can upsample this plane to a larger resolution, but also we can pad the small plane to the larger resolution. But I think no matter pad or upsample, I think it brought some dummy information which may not improve our score. So I try to keep the resolution close or smaller than the shortest edge of each plane, which is listed in the tabular. The larger resolution of most of my models is 512. And here is all of my 4 models contains in my 2 submissions. One submission contains 4 models. It's the last line, which is the ensemble. And another submission is a single model inference with the UNet as with the backbone max VIT. And since I observed that different kidneys has a large variance on intensity, so I used a very heavy argumentation on intensity. Also, as introduced before, I trained on all the kidneys. So in fact, discarding the validation set is usually a very risky strategy. But in this competition, I observed the model converge very with a great converge very stable after a certain epoch while training. And I believe that I may use ensemble in my submission. So after ensemble, I think the score may be more stable, no matter which epoch we pick. So I decided to train on all the kidneys to make my model can train on a wider data distribution. Also, to accelerate the training, I resumed the weights from the last step in the process of pseudo label with a smaller learning rate instead of training from scratch. And I think another key factor that my model survive in the shake is that my model has is not very sensitive to the threshold. It only changes about 1.5% from the threshold changing from 0.1 to 0.5. So I think it's stable to the threshold changing. And about the here is the ablation about the previous tricks I introduced previously. First, the most important part is that the pseudo label strategy. If I don't refine if I don't refine the label and keep all the other tricks, the model has a very significantly drop. And if I don't simulate the magnification, it has a slight drop from the second line to the third line. And also, training on all the data is very important, as introduced in the last line. So here's some quick ablation. And a magical observation is that I don't know why the UNet with the SERES Next as backbone has a very high private score, especially with a lower threshold. I think it's a magical observation, and I can't explain why. And here's all of my presentation. Thank you.